This is part 5 in our videos for chapter 5. In this video we're going to talk about some additional processing patterns that loops are usually used for. Again, a good program allows the user to control the repetition. We have seen two ways of doing that. One is the user can specify a sentinel value that marks the end of an input, but also a user can specify the number of input values to be treated. In both of these, and when the number of inputs is specified, it must be read prior to trying to read the actual data values. So count-driven processing is based upon the concept of a counter, and a counter and a loop tend to go together. So a counter is a variable that is incremented or decremented. That means you add 1 to them or 2 or subtract 1 from them each time a loop repeats. And a counter can be used to control the execution of a loop, as in the for loop. Because in the for loop we basically can use a counter. We can give the initial value of the count, we can give the amount by which we increment the count, and we can also set the limit on the count. If the counter is being used to control the loop, then the counter must be updated, and that update must either occur within the loop header, that is in the for header, or in the while header, or it must be within the body of the loop. Here's an example where we want to generate outputs. We want to generate a specific number of lines of output, and we call that the limit. So the program begins by asking how many entries do you want to have in the table, and that sets a limit. The for loop then counts from 1 up to that limit, and for each count that is below the limit, or each count that is not outside of the limit, we're going to output a line of output. Okay? Notice that if the repetition is controlled by counting, it's preferable to use a for loop. You can also use a while loop, but I really do not advise it. One of the things to learn in this class is what's the appropriate tool to use in a given situation. Now, there are other loop processing where the goal is to compute an answer, and the answer is obtained as the result of looking at lots of data. One such example is the adding of a list of numbers. The variable that is in use when we are doing this is called an accumulator. An accumulator is just a running total. For example, if I'm adding a list of numbers, if I keep the total in my head, I have a running total. If I add 1, 3, and 5, I say the answer so far is 1 plus 3, which is 4, and 5, which is 9. So at any time I can be asked, what is the answer so far? And that's what a running total does. Now, the accumulator need not be something that you add. You can, each time through the loop, you can do some other operation to update the value of the accumulator, such as adding, subtracting, multiplying, dividing, or even taking the mod. And so there are basically two kinds of accumulators. Accumulators that are based on adding or subtraction, and accumulators that are based upon multiplication or division. The initial value of accumulators when you add is a 0. The initial value of accumulators that involve multiplication or division is a 1. Here's an example. We want to get the sum of n input values. We're asking how many values do you want, and you're told the number of values. Notice that the control of the repetition in this case is based on counting. So a for loop is the appropriate construct. So we have a counter that goes from 1 to the number of values. What is done each time through? We read a value, add the value to the sum. So the variable sum is the accumulator. It's based on addition. Therefore, we initialize the accumulator. And notice that the initialization of the accumulator must occur before you start processing the data. Another example. If we want to get the product of n input values, notice that these will be pretty much the same. The variables of interest are no longer sum, will be product. We're not adding, we're multiplying. And finally, our accumulator is based on multiplication, not adding, so we will initialize it to 1. So if you look at the code, you see pretty much the same, except that we've accounted for the fact that we're getting the product and not the sum. Again, we're using a for loop because we are doing this a specific number of times based upon the input value, num_vals. Here's another example. If the goal is to read inputs and add up all the negative numbers and add up all the positive numbers, then what do we really have? Well, in this case, we have two variables, sum of the positives, sum of the negatives, and each one of these is an accumulator, so we have two accumulators. What do we have to do with accumulators? We must name them, we must declare them, and we must initialize them. Both of these accumulators are based on adding or subtraction, so we initialize them to 0. Where do we initialize them? We initialize them before we start processing the inputs. So that must go above the loop. What kind of loop are we using? We're using a for loop because we are counting the number of input values that we process. Now let's look at the code. We're going to read a number and we must determine if the number is positive. If so, which accumulator do we want to use? We want to update sum pos. Otherwise, we need to see if the number is negative. If so, we update the sum neg accumulator. Now, why did we say else if rather than else? Well, what are the three possibilities? A number is greater than 0, is positive, is less than 0, or it is 0. So we want to make sure that we don't mistake a 0 for a negative number. That's why we must separately test to see if the number is negative. All right, so let's run this little program. We have this one running, and we are going to run it. We're going to run it. How many input values? Let's say 5. We're going to put 0, 0, 0, 0, 5 values. And what are the sums? There are no negatives and no positives. Let's do it again. We're going to do 4, 3, minus 2, 0, minus 4. And we see that we've added the two negatives. We've added the two, whoa, got an error here, don't we? Dun, 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 dun. Oh, no we didn't. I said there would be 4 inputs, and a positive, a negative, a 0, and a negative. I wasn't paying attention. All right. Now, here's another example where we are using an accumulator, and you don't think of it as an accumulator. Remember what we said earlier about the notion of an accumulator? We said it's a variable that provides you the answer so far. Every time you get a new input, you may update your view of what the answer is so far. So there are lots of problems that are solved this way. One such problem is getting the minimum. So let's look at this very carefully. We need a variable called minimum value, and it is the accumulator. What is different between this and the previous examples is the accumulator is not updated by doing arithmetic. It's updated by changing our mind about something. So if we're trying to get the smallest of a list of inputs, you must start off right. So what's the initial value? If I'm adding, I can just say it's 0 to start with. If I'm getting the minimum, I don't know exactly what the starting value of the answer should be. The safest thing to do in the case of trying to get the minimum or the maximum is to make the first input value be your answer so far. So the first thing we do is read the first input, and we're going to call it the answer because it is the answer so far. The second thing you note is that we've already handled one of the inputs, so now we need to start counting. We need to start our count not at 1 because this took care of the first input. We now start our count at 2 and go up to the number of values. Notice that. And the last thing we say is we are going to read an input value, and we're going to see if this is better than the answer we have so far. So how do we do that? Let me make an example. Suppose I read in the first number is a 5. And we'll say the answer so far is a 5. I read in the second number is a 2. Which one is better for the answer? Is it the 5 or the 2? Well, it's really the 2. So this if statement compares the number with what we think the answer is, the minimum. And if the number that we have is less than the minimum, then the minimum so far needs to be adjusted to become that number we just read, which is the 2. So that's our approach to solving the problem. We will demonstrate that with this program. Here's what the program looks like, and we're going to run it. I need 4 values, and it's going to be 4, 3, 2, and 0. And it says the minimum is 0. So what if I give it 4 values, and it's 3, 3, 3, and 3? What do I have? The minimum is 3. Last time, if I have 1, 0, 7, minus 5, what do I have? I say the minimum, did it wrong again. Number of values is 4, and I have 1, 0, 7, minus 5. It gives me that. Okay. So with that, we have ended this video.